Thank you very much. I'm so happy with you all again, and assalamu alaikum, and thank you for the invitation. This year, in the session of environmental processes and protection, I thought to give you a keynote with some ideas on teaching. What? Yes, most of you are academics and are in contact with students. Students will go to industry or administration or become researchers. I would like to share ideas of scholarship of teaching and learning with you. Scholarship of teaching and learning is a scholarship for lecturers for research on higher education. So relax, it might be a bit different to membranes, but I hope you will see why I'm talking to you, why you are a researcher on membranes, and I hope it is interesting and inspiring for you. So what I want to do is to go first into the idea of sustainable development and environmental protection, and what this means for students and lecturers. I want to show you holistic learning settings, what we are doing at the Metabolon Research Center at the University of Applied Science, where I am, and show you some of our ideas and what we are doing there. So learning for sustainable development and shaping the future. So this is what young people all around the world are thinking about. What will the future be? What will happen? And as lecturers, we have to discuss this also. And so the question is, how can academic education process contribute to lead students to actively participate in developing sustainability technologies? This is what we are discussing in this conference, to develop technologies, and how can we really grasp the students to do it and to support sustainable and social development. So at the University of Applied Science in Cologne, we discuss a lot on those headlines like employability. What can we do to train students today to have still a good job in 40 years? Because this is the lifetime you have to work for. How to contribute to global citizenship, to responsibility to protect our environment and to adapt ourselves. So this is a long life learning concept. And we say that we want to bring this knowledge to the students. But this means a big question to us. This is the requirement for students and lecturers. There's a lot of things happening. Yes, we have this digitalization thing. We want to have sustainability. We need economy, social aspects, knowledge, globalization, uncertainty, and things are changing all the time. And how can we as lecturers bring this to the students? So it is important to know that since we have all these artificial intelligence tools, well, a pure specialist is mandatory for sure, but not as mandatory as 100 years ago or 30 years ago, because a lot of things you can look up in the internet. Yes, now I'm sitting in Germany and I'm part of this wonderful conference in Egypt, and we have all these connections. We know a lot of things more. Information is growing. We have a lot of information and we have to sort this information. And so I'm not sure if you have this in Egypt too, but in Germany, we discuss a lot about the learning objective competencies. And well, what is this? And I looked it up in research book for teaching, and there's written that competencies are abilities to act creatively and self-organize in open, unmanageable, complex, dynamic, and sometimes chaotic situations. I think even your research daily work is sometimes chaotic, and this is where we need the competence to work in. And now I come back to these environmental issues. Competencies based on the knowledge, yes, knowledge we still know, qualifications and norms and values. Norms and values within a society or within a research group. And when we go to the environmental processes, we have now more than 50% of the world's population living in urban areas. And we have an abstract picture of the natural environment. Yes, in Germany, there are always signs. Here is environment. Please protect it. Please be sensible with it. It's a little bit like going into a museum. And without knowing the environment, the environmental processes, it's difficult to protect it. Because how can you protect things you do not really know and understand? And the concepts of circular economy and bioeconomy are based on natural processes and cycles. And so the development of sustainable environmental processes is based on everything what is underlying in the technical and natural processes. And now, in addition to the specialist notes, we in environmental protection, we know to make decisions under uncertainty and to know the global issues. I go one step deeper, observation and hypothesis. This is a hypothesis for me for research in lecturing. We know that the training of engineers is characterized by teaching the scientific and technical background in clear approaches to solutions. And we have predictable problems. But in environmental sciences, we have global interactions, environmental media going across borders, anthropogenic actions cross borders, and we know we need to combine this. So this was very abstract, and I know that this is a totally different theory compared to membrane background and theory. So I will give you an example. The River Rhine is in Germany, and the Nile River I know is in Egypt. And both rivers have one thing in common. Well, Nile River is much bigger than our Rhine River, but it is a very long river in Europe. And both rivers are crossing different countries. And we have in Germany, we have the Netherlands, Belgium, Switzerland, and I know in Egypt you have the Sudan in the south and other countries. And you in Egypt are at the end of the Nile River. So everything what is happening in the countries before is happening with you. So you can do best treatment of water. If it's not done in the other countries, you will have muddy water. The same thing is with us. When we in Germany, with our chemical industry, pollute the Rhine River, the Netherlands are, well, not very happy. And this is why environmental issues are cross borders. And everything we are doing with environmental protection and membrane technology, for instance, is coming from the nature. Yes, everything we are doing in membrane science comes from the nature. I brought you here a picture of a cell membrane. This is the basic idea to separate molecules, salts, and so on. And this is what we are discussing here in the conference all the time. Yes, you want to develop wonderful processes, wonderful membranes, and everything comes from the nature. This is what we want to show the students, that the nature is giving us the basic ideas. So now we come back to the theory of the holistic learning scenarios. We say we want to combine the science, what we see in the left of this triangular thing, and science is what we want to train the students. Yes, we want to give them the theoretical background, but we want to go into a process learning that they even apply their knowledge in practical context, that they know how to collaborate in project teams, that they know how to implement and validate solutions, and that they think about what they did and how the learning process was. And we want to train the individual person to give it awareness of the acquired specialist knowledge, that they really know I am a specialist on membranes, but for other things I need a specialist example for construction of a building. And so it is important to combine the specialist knowledge with the understanding of the environmental global processes, and to know a way to make decisions and to reflect their decisions, or another important point today, the decisions proposed by artificial intelligence tools. I give you an example. This is a wonderful wastewater treatment plant. I think you would agree. Well, this is a technical drawing by artificial intelligence. And it took me one prompt, one question to the artificial intelligence tool to draw a technical drawing of a wastewater treatment plant for a city with 258 inhabitants. I asked this yesterday when Frank Rögner made his presentation to show you how quick this is going. The plant will work with membranes and fully recycle household wastewater. Imagine now you are a decision maker in an administration and you want to buy such a plant, and a company is coming and they just show you this picture and say, yes, this is everything. Please give me your money and I will construct it. Here's the next one. I just said I want to have a technical drawing of a membrane plant. One prompt. And I think if I would ask the RE, I think 10 times, it would be a wonderful drawing of a plant. However, it will not work because the knowledge is not behind it. And these things are important to train the students, that a picture is not a functional plant. And they have to understand that all the information available are not the competency to work with it. So what we are doing at the Metabolon is we have a holistic learning and research area for sustainable development at the Cologne University of Applied Science, and it is situated at an old landfill and an active waste management area. And it is a cross-faculty learning center. So cross-faculty means we have engineers there, we have students from economics, from social science, and so on. We have wonderful learning areas, and we have labs and plants, even technical scale plants. And we can do a lot of things there. And I will give you 2 examples. One example is called Camp Metabolon. It's a holistic teaching project for circular economy. You see here the circle of circular economy, and traditionally we focus as environmental engineers end of pipe on the residual waste. So we ask the students, what does circular economy mean for product design, or how can product design contribute to reduce residual waste? And we went with the students into the waste. Yeah, it's really ugly to go there, but they had gloves and protection things, and they went into the waste, and they started with the redesign, the beginning of the cycle of the materials. And here's again one filtration thing, because they found a filtration, a filter. And you see this picture, it's called loofah. And loofah is a plant, and they said, okay, this filter looks like this loofah, perhaps we can create a compostable filter media. Yeah, these are different things and ideas they discussed, and it is to restart the thinking of what we are doing. Another thing is, we did it this summer semester. It's walking around, a holistic teaching project for environmental process technology. And we walked around in the environment and watched which unit operations we can see which are used by nature. So we can see by nature precipitation, ion exchange, solubility, filtration, air scrubbing, adsorption processes. You see here two pictures and you see this brownish water. It's no pollution from industry, it's just iron and mangan oxide, which is precipitated when the water comes out of the soil. And these things we watch with the students. And now you can imagine what this means for training the students even to develop, for instance, membranes or processes. To come back to the nature and to think about what you really see and what we want to do, to think about that nature is working well with low energy demand and with solar power and all these things. And this is what we are doing. Okay, what happens next with us? We want to combine knowledge, qualification, and internalized rules, norms, values of the society and of the respective professional area to competencies. We will do a transdisciplinary learning setting in the winter semester with a hackathon where engineering, social science, and economics students will meet the local industry and within 3 days develop ideas. I want to create a teaching project. How can natural environmental processes be applied for the development of unit operations like membranes? We want to have a teaching project, climate change, climate adaptation. And we are developing transdisciplinary modules for the inclusion into different courses of study. This means for students from economics, from social science, from design, and so on. Yes, and that's all. And I'm open for any questions, and I hope you had a little bit of inspiring fun with this a little bit strange thing. And I'm very interested what is going on today with membranes.
Thank you, Dr. Miriam, for your interesting presentation today.